Let's start using the AssistantJS command line interface to create a new project. Just open a console session and type assistant new my bus application. As you can see, this will create a project directory and set up some initial files and folders. The project setup also tells us to run npm install afterwards. So let's switch to the project directory and run npm install. Alright, your project is now ready. In the first step, we want our application to say welcome to my bus company as soon as it's launched. So it's time to dive into the code. Let's first have a look at the folder structure to the left. As stated in the wiki article, states are the backbone of your voice application. AssistantJS already created two state classes, one of them being the main state. The main state represents your initial state. As long as you don't switch the state during a session, your application will stay in the main state. But there's another special thing about the main state, the invoke generic intent method. As already explained in the wiki article, this method is called once your application is launched. So if a user says something like Alexa, launch my bus company, AssistantJS will trigger exactly this method. This also means the invoke generic intent method is our place to go for implementing our welcoming message. If we want AssistantJS to respond to an assistant, we need the response factory, which is already set up in this state. The response factory has several options to send a response. We are choosing create voice response to create a voice response. As you can see, you can choose if you want to end your session or keep it open after emitting your voice message. Let's keep it open using prompt so the user is able to say something after our welcoming message. In the wiki article, we also described another intent, the bus route intent. This intent shall be triggered if the user says something like, when does the next bus to the train station arrive? Let's create the intent by just implementing another method. Currently, we just want our bus route intent to respond with a static voice message. By the way, intent methods can be async too. If your intent method returns a promise, AssistantJS will wait until it is fulfilled. So, if you ever need some asynchronous activities, just declare your intent method as async and you are able to use await calls. As you may know, we have to tell assistants like Alexa or Google Assistant what the user can say to trigger a specific intent. This is done through utterances. In AssistantJS, we put all our utterances in the utterances.json. We just need to add the created intent method name as a key to this file and are then able to put as many utterances as we like in this resulting array. To make the process of creating utterances smoother, AssistantJS also supports a template language to define variations of utterances. For example, have a look at our utterances, when does the next bus to the train station arrive? Let's create a variation of it using will instead of does. Now AssistantJS knows three utterances. How do I get to the train station? When will the next bus to the train station arrive? And when does the next bus to the train station arrive? So we set up our first state and our first two intent methods, but we did not configure any assistant yet. To try our voice application, let's integrate it with Alexa. You should know AssistantJS is strictly component-based. You are able to opt in features you need and opt out features you don't need. This means integrating a new assistant, like Alexa, is just a matter of installing and configuring of all responsible components. For Alexa, the responsible component is called Assistant Alexa. Let's install that with npm install save assistant Alexa. Afterwards, we have to tell AssistantJS that it should use the Alexa component. To do so, open the index.ts and import what we call the component descriptor and pass it to the register component method. Next, we need to do a tiny bit of configuration. This is done in the config components file. First of all, I'm importing the configuration interface of the Alexa component to be able to create an instance of the configuration. And in this configuration, I have to pass the application ID, which is unique for our skill and identifies our skill to Amazon or for Amazon. I will also pass a route, which I will recap later, and set the verifier to false, so to disable the verifier. This actually will just make testing a little bit easier because the verification of the Alexa signature will be disabled in that case. We also have to add this configuration to the hash below. And we're done with configuration. With that set up, we can run the AssistantJS generator. Just open a console session, compile your code, and run assistant generate. The AssistantJS generator will scan all configured assistants and create a configuration build for them. After running the generator, we can switch to the builds folder of our project directory. AssistantJS creates a subfolder for each build named with the timestamp of the build. Inside of this subfolder, we find another subfolder for all languages we use, in this case only the English language. And then we find the folder for the Alexa build. Inside of this folder there is the schema and the utterances. So a list of all utterances and the schema.json. Just copy the contents of these files, paste them into the skill configuration, and your interaction model is set up. Now we need to start the assistant server with assistant server. Per default, the assistant server is pretty quiet, but now we'd love some debug output. That's why we're setting the debug environment variable to assistant and assistant Alexa. The problem with our assistant server is that it currently runs locally only. This makes it impossible for Alexa to call it in our tests. That's where ngrok, or however it is pronounced, helps us. ngrok is a pretty small tool you can download over here. What ngrok does is that it tunnels your locally running application to the internet. We just need to tell ngrok on which port our server is running. Per default, AssistantJS runs on port 3000, so let's start an ngrok tunnel on this port. You see this URL? This URL now links directly to your application. That's why we can just copy it and paste it into our skill configuration. But notice that we also have to add our Alexa route, Alexa, to the URL. This is the route we configured earlier in our components.ts. Alright, everything is in place for trying out. Let's use our bus route intent by asking when does the next bus to the train station arrive. And we see our static response. It works. It's also worth taking a look at the debug output. We see the whole Alexa request. We see Assistant Alexa, the Assistant Alexa component, saying that it can handle this request. We see AssistantJS saying that it calls bus route intent on state main state. And we see the whole response which is delivered to the client.